Okay, so now we're going to introduce a concept known as electron dot structures or Lewis structures, and this will give us a tool to be able to figure out why elements bond the way that they do. Lewis dot structures for elements are very, very simple. What we're going to do is you're going to draw the elemental symbol, and then you're going to put dots corresponding to the number of valence electrons that atom has. Okay, so as is usually the case, we'll go through a few examples and hopefully it makes a little bit more sense. So if we want to think about drawing the Lewis dot structure for carbon, draw the symbol, then we look at the periodic table, try to figure out how many valence electrons carbon has. Of course, you can look at the group 4A. It'll tell you that carbon has 4 valence electrons, or you can look at the electronic configuration, 1s2, 2s2, 2p4, 4 valence electrons. So what we're going to want to do is draw 4 dots around carbon. Okay. What about something like oxygen? Oxygen has 6 valence electrons, so we're going to go 1, 2, 3, 4, 5, 6 valence electrons. Okay. What about nitrogen? Nitrogen has 5 valence electrons, so we go 1, 2, 3, 4, 5. Neon. 1, 2, 3, 4, 5, 6, 7, 8. 8 valence electrons. Of course, they're very stable. Have the octet rule. And then let's do even something a little bit simpler. Sodium, 1 valence electron. So before you know it, you're done with sodium. Okay. So now, is there a right way or wrong way to draw Lewis dot structures? And in general, there's not really a perfect correct way. We could have drawn sodium like this, or oxygen like this. That doesn't really matter. Usually, unless I'm trying to, show a specific example of bonding, I usually go with the usually go counterclockwise. Excuse me. I go clockwise. 3, 4, 5, 6, 7, 8, and those are my positions where I want to place the electrons. I always want to group the electrons as paired and very close to the elemental symbol. I don't want to do anything like this, because that starts to look like a bond, as you'll see, and you're never going to put more than 2 electrons by each other. So let's use Lewis dot structures to determine how very simple molecules or simple compounds will bond. Okay, so let's take an example of fluorine, F2. We know fluorine is one of the diatomic molecules. Okay, so how does fluorine bond together? Well, if we draw the Lewis dot structure, 1, 2, 3, 4, 5, 6, 7 valence electrons, okay, and next to another fluorine atom with 7 valence electrons, okay, we can do a couple of things. Let's think about forming an ionic bond. Okay, we can transfer this electron to the other fluorine atom, and that will produce a fluorine cation. 2, 3, 4, 6 with a +1, and a fluoride ion with 8 valence electrons and a -1 charge. Okay, so this could potentially form an ionic bond from the electrostatic attraction from these ions. But the big problem with this, doing this way, is, okay, we've got 8 valence electrons for the fluorine atom on the right, fluorine ion on the right, but this one only has 6 valence electrons. Okay, so this doesn't work for fluorine. So instead of transferring electrons, fluorine will share a pair of electrons and form a covalent bond. Okay, so when you look at this molecule, you would assign this line that corresponds to the 2 valence electrons that are being shared, and you would associate those with both atoms. So over here, this fluorine has 1, 2, 3, 4, 5, 6, 7, 8. and this fluorine atom has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons, and that's why fluorine F2 forms a covalent bond rather than an ionic bond. So what you want to do is you want to figure out a way, using Lewis dot structures, to achieve the octet rule for both atoms in the most efficient way. Okay? What about something like sodium fluoride, NaF? Okay? We know that sodium has 1 valence electron, and fluorine, of course, has 7. So it turns out in this case that if sodium gives up its 1 valence electron to form a cation, and fluorine gains that valence electron to form the anion, this will form a stable ionic compound, because remember, if sodium loses that 1 valence electron, it goes down to a 1s2, 2s2, 2p6 electron configuration with 8 valence electrons. Okay, so this turns out to be the best way to achieve the octet rule for both atoms, and that is, of course, through transfer of electrons and an ionic bond. Okay. The only other thing we need to worry about is for very, very small atoms, such as hydrogen. Remember, hydrogen is fine with the duet rule. Okay, so when it forms a compound with, say, HF, it will just share 1 pair of electrons with fluorine. So we'll give 2 electrons for hydrogen and 8 electrons for fluorine, and that will make a stable compound.